Hi, my name is MD Aminul Shagor. I am a PhD student in the Department of Civil and Environmental Engineering at Clarkson University. Today, I will be briefly explain our research on fish responses for different boulder arrangements and implications for aquatic connectivity. As you already can see, my research title, which is Experimental Investigation of Fish Responses in the Natural Lake Fishways, Implication for Aquatic Connectivity. Before going to my main research, let's imagine trying to cross a busy highway without a bridge or a safe crossing path. Most of us would struggle to continue our journey, right? Fish face a very similar challenge in rivers today. Many rivers are interrupted by human-made barriers, such as dams and culverts, which block natural migration routes and make upstream movement difficult. However, fish need to move upstream to reach important habitats for feeding, resting, and spawning. To help address this problem, engineers develop nature-like fishways that mimic natural river environments using rocks and boulders that you can see on the image. These structures create safer migration pathways, reduce flow intensity, and provide resting areas where fish can recover energy while moving upstream. Slight Although nature-like fishways are increasingly being used around the world, several important questions still remain unanswered. We still do not fully understand how the spatial arrangement and density of boulders influence fish movement behavior. Rocks and boulders can change local flow conditions and create low velocity refugee zones, which we call wake zones, behind the boulder, where fish may rest, but their overall impact on fish movement and energy use is still not clearly understood. In this research, we are testing different random boulder arrangements under both low and high flow conditions. In a laboratory fishway, we track Atlantic sailboat movement using an overhead camera system and analyze important behavioral responses such as resting time, passage time, ground speed, upstream passage efficiency, and fish movement pathways. Our goal is to better understand how boulder arrangement influences fish behavior and to link those responses with local turbulence conditions to improve future fishway design. Now, talking about experimental methodology and fish characteristics that we used, to investigate fish movement behavior, we conducted controlled laboratory experiments in the ecohydraulics flume at Clarkson University using four different boulder arrangements, juvenile Atlantic salmon with an average length of 13 centimeters, were tracked using an overhead camera, as you can see, camera system under both low and high flow conditions. We then analyzed how different flow environments influence fish movement pathways and behavior. Talking about the results and discussion, these figures show how fish movement pathways changed under different boulder arrangements and flow conditions. In the no boulder case, fish mainly moved along the side regions and avoided much of the middle zone, especially under higher flow conditions. Here, by mentioning higher flow, we are mentioning 70 liter per second or 0.07 meter cube per second. In more stratified arrangement, fish used more distributed movement pathways throughout the channel. Here, the change in kinetic energy gradient was more gradual, allowing fish to utilize multiple movement corridors instead of depending on a single preferred pathway. The alternating flow conditions between boulders also created intermittent refugee zones that supported upstream movement. In contrast, the clustered arrangement created elevated high gradient zones and more localized turbulence region. Under high flow conditions, fish appeared to avoid these highly disturbed areas and instead selected comparatively lower gradient pathways around the clustered region. Our overall findings suggest that boulder arrangement plays an important role in shaping hydraulic conditions and fish movement behavior in nature-like fishways. Understanding these interactions can help improve future fish passage design and support better aquatic connectivity in rivers impacted by human-made barriers. Thank you.